Hello viewers, welcome back to another FreeCad tutorial. This is going to be a very interesting tutorial on fundamentals of animation in FreeCad. We are going to assemble slider crank mechanism and animate it. Now, why animations in CAD? This is done to verify your kinematics are accurate in an assembly. Kinematics are defined as motion of objects. Here in this tutorial, I'm going to walk you through step by step, and once you fully grasp the fundamentals, you could do any assembly motion in FreeCAD. Understanding the local coordinate systems is key to this tutorial, and there are several previous tutorials I posted in YouTube that I recommend you watch. When you subscribe to my channel, you will have access to these videos. Video links are also in the description. I would really appreciate your subscription to my channel. In this video, I'm going to start with the importing the piece parts of the assembly. So I'm going to open up the folder. So I have 4 parts that consist of this assembly: crank, cylinder, piston, and shaft. So I'm going to import all of them. So you can see this is I call the shaft, and this is the crank. And then we have the piston, and then the cylinder. Okay, so now what I'm going to do is I'm going to create a new model, and this is currently shows as unnamed, and I can rename it something like, say, piston assembly. Now since we are in this, I'm going to go to assembly 4. Now assembly 4 workbench is something that that you need to install. Now I'm not going to show how this can be installed. There's a video that I created earlier that shows how you could install the assembly 4 workbench. So I'm going to put the link to that video, and that video will be useful on how this the model is created. So if you go and watch that video, that will give you some I think foundation for you to understand this video better. Okay, so please go and watch that video and then come back. So now, since I am in this, I already created this assembly. Now I go and let's create assembly. So that this is the button you have to create. It's called the assembly container. Now you have consists of 2 things. There's a parts folder, and then the assembly underneath that. Okay, so what you have to do is to bring all these 4 parts into parts folder. Now in the previous video I mentioned earlier, this is discussed in detail. So since it is already discussed in that video, I'm going to just kind of go a little bit fast and show you how to drag and drop these parts into this folder. So what you have to do is you have to go and copy and just say okay, and then go to this folder and then paste it. Now you can see that part is copied. Now if you go to, so since I took the piston into this, so I don't need this, so I'm going to just close this folder. Then Same thing you can do for the cylinder. Just say copy and go to paths and paste it. Now I'm going to, there's a recompute icon is appearing here. I'm going to just press F5 so that it will automatically recompute that. So I got two parts, and I'm going to close the cylinder, and then I'm going to copy the crank. And so now I have to bring the shaft in. Okay. So I got all the parts in, so I'm going to close off and only keep the assembly model. So as you can see, all these parts are kind of in a random space, okay, and that's how it is, because you created all these parts in a separate models, and so you don't have any specific relationship. So what we are going to do is, in this assembly we are going to create a relationship between all these four parts, and then give them a motion that would be they have certain constraints associated with that motion, and that will create this piston assembly or the crank motion of a piston assembly. Okay, so now since we got all these parts in, what I can do is next is start putting together assembly for these parts. Okay, now I don't need to have them visualized at this point, so I'm going to press the space bar and make them inactive, or kind of hide them. Okay, now I have the empty space here. I'm going to activate this assembly by double clicking. Now the assembly is active. I have separate videos on all of them, how to make the parts active. If you go and watch my videos, you will see. So in order for you to do that, please subscribe, then you will see all my videos, and then you can pick and choose which one you want to watch. So the next step is for me to create a sketch in this workspace. Now this sketch that I'm going to create will define the slider crank mechanism. Now there are a couple of purposes of this sketch. First is I can locate the piece parts using the sketch, and then assign a motion to the those parts. Okay, so how do I create a sketch? So the easiest way I'm going to do is to use this sketch within the assembly 4. Okay, now I'm going to activate this origin for this case, so that I can pick a plane that I want to create this sketch. So let's see which plane. I want to pick the XY plane. Yeah, so I can see the XY plane here. Now I can start creating a sketch. I don't have to rename it. I'm just going to keep it as it is, and I'm going to pick attachment mode. So I'm going to say plane face is my attachment mode. Now I have created this sketch. Going to press F5 to recompute it. Now once I go into this sketch, you can see I'm in the XY plane. You can actually pick any plane you want, and now I'm going to start creating the slider crank mechanism. So okay, I'm going to give some length. Let's see, some length here. We are going to dimension this. Okay, I'm going to pick on this line. It's going to give some dimensions to it. I have a specific dimension I want to give. Now even though I'm not going to show you every step, there is a geometric relationship that already built in. That's why I give this specific dimension, okay, based on the size of those components I already imported. Okay, now I'm going to give a dimension to these as well, 4.2 inch, and I'm going to define the angle as well, say 60 degrees. So now my sketch is fully constrained. I'm going to get out of that. Now of course it is kind of oriented in an awkward way. Let's see how we can get my XY plane back. Maybe top view. Yeah, okay, the top view will give you that the proper orientation. Now next thing is I'm going to create a variable within the assembly. Okay, now variable can be created using this add variable button. Now you don't have to create it right now, but I'm going to create it now so that I can show you how this works. So I'm going to say angle, say rotate. Now this variable we can let's go and see. Okay, I have 10 already defined here. Now this variable needs to be assigned, so it needs to be assigned within the sketch. So I'm going to open up the sketch, and what I'm going to do is use this angle, and I'm going to assign the variable to this angle. Okay, so the way to do that is variables. Now there are videos that I have created on all these, so when you subscribe you will see these videos and you will be able to see the fundamentals behind each of these steps. Okay, so say angle rotate. Now the reason why it changed, because as you saw earlier, my angle was in the variable, it was defined as 10 degrees. So if I go back and change to 60, you can see it changes. Now I can actually animate the skeleton. Okay, what you have to do is, this is the animate button, and you can currently this is you can say, okay, I'm going to pick this guy, and let's see whether do I have a document. It somehow shows as unnamed. Let's see how this works. Let's start with 0 and see 360 degrees, see how it animates. So you can see that it's actually do like a okay, rotate it, and I can stop it. So we'll play more later with this animation. For now, just I'm going to close it. Okay, we're going to come back and start playing with this animation and give more details on it later. Okay, so of course I can change this back to 60. One thing I forgot, let me go back to this sketch. There's one more item I need to add here, and you will appreciate it later why I'm doing this. I'm going to add another line here. Let's say give it some dimension, say 1 inch, and I'm going to make it perpendicular. Okay, so I'm going to constrain it perpendicular to this line. So now my sketch is fully constrained. Go get out of here. So my sketch is ready so that I can start importing parts into the sketch. So next step is for me to create 3 local coordinate systems at each of these vertices. Okay, Why do I need them? I'm going to assign or align my paths to with respect to those local coordinate systems and create motion. So let's do that. Now I don't need this origin, so I'm going to hide that. Now I'm going to use the this local coordinate system creation button in the assembly 4 datum assembly 4 workbench to do this. So let's start with first one. I'm going to assign it here, then I'm going to pick the translate origin that will move it, that coordinate system to that location, then pick the second point, and it created the inertial coordinate system as so I don't need that. I need this OXY. Now I have a video in detail explaining this, so if you subscribe that, and I would highly recommend you subscribe to my channel and go and watch that video, which is called Datum, Planes and Local Coordinate Systems, which will clearly explain the menu here and how to define properly a local coordinate system. Okay, now I'm going to pick OXY, that will move the coordinate system here. I would like to have my X aligned vertically. That's my preference. You don't have to really need do that, but that's my preference here. So I have defined that now fully. Now the X, these colors actually define your X, Y and Z. Just like here, red is X, green is Y, and Z is your blue, and that's how FreeCad define the local coordinate system. Okay, so I say okay. So next thing, I'm going to create a second local coordinate system at this vertex. So in order to do that, I'm going to actually hide this guy. And let's create that second one. And pick this vertex as well. Say inertial coordinates. Actually, I don't want inertial, I want it here. So I'm going to pick align OXZ. And for the third point, I'm going to pick this guy. So now if you see, my coordinate system is axis aligned in this direction. So that's what I want. Good with that. I'm going to close it and exit. So for the third coordinate system, I'm going to create here. I'm going to hide this one, and before creating that third coordinate system, I want to have another point created here, because in order to fully define my local coordinate system, I need another point here. So I'm going to create this point using the method here. So now I can actually this point is already it's not located here, so I'm going to put this guy here, and then its attachment mode is not defined. Then I'm going to define it by center of mass, and this I'm going to see which coordinate will work. See, okay, so the Z actually is in this direction, the same thing I want, so I'm going to keep it that way and say okay. Now I have this point already created. Now let's go back and create that local coordinate system. So I need to pick this point. It's at the right location, but it's not picking that vertex, so that's what I did. Second, I'm going to pick this vertex. Now I want to go inertial coordinate system. If I want to do that, I can do it, but I don't want that. Let's see which one I want to go. Align OXZ again. And now for the Z, I'm going to pick this point. Now that define my all the three coordinate system. Okay, so I got pretty much all three defined the way I want it. You could rename these local coordinate systems. So in this case, or just only three, I'm not going to rename it. I know this one is 1, this one is 2, and this one is 3. So but if you have more than like 10-15 local coordinate systems, you probably want to give some meaningful names for them. Okay, now next step is actually what you want to do is go ahead and take a screenshot of this, because we want to remember, and I'm going to move it aside, but you want to keep in mind how you define these coordinate systems, because what we will be doing is will go into each part and define a set of coordinate systems, local coordinate systems that kind of replicate these ones. So the rationale for that is, once you created similar coordinate systems in each of these parts, it's very easy to move them and attach them to this coordinate system. Okay, that's the reason for doing that. So another thing to keep in mind is that you could animate this and see whether these coordinate systems start flipping around. Now when I say flipping around, it's that it just takes this direction changes suddenly. Now I have seen this question come up in FreeCad forums, where they have a part that is attached to a coordinate system, and then as the part rotates or translate, it start flipping around. And that's because if you don't have your coordinate system fully defined, that could happen. So let me demonstrate this and see whether we have systems that are fully defined and they don't flip around. So it seems like it is holding up. The directions remain static, even though the overall crank, the slider crank mechanism rotates. The coordinate system's directions hold up. So that means this is we have defined our coordinate systems correctly. Now next step is, what I want to do here is I have these paths and I want to assign local coordinate systems to each of these paths. And once you assign them, you can bring these paths into the assembly and aligned against these three coordinate systems. So for instance, the piston will be aligned here, the crank will be aligned here, and then the shaft will be aligned here. So ultimately when you animate this, the parts will start moving according to the aligned coordinate system. Okay, now how do we do that is, first we are going to activate each of these paths and create the coordinate system. So this one right now, the piston doesn't have a local coordinate system. So first thing is I'm going to do is I'm going to hide this guy, Now this is the piston. Now I'm going to align a coordinate system to this one. So in order to do that, what you have to do is to make this guy active. So let's go and make it the active body. I don't know why this FreeCAD keep flipping back to the part design when I do that. So you have to go back to assembly. It's kind of annoying a little bit, but we'll get around that. Now I'm going to create this local coordinate system in this part. Now I can pick this and say concentric. So now I have the local coordinate system defined here. Now what I can do is I want to have my x in vertical direction. So to be consistent with the local coordinates assigned in the sketch. Okay, so as I said earlier, it would be easier if you align your piece part coordinate systems same way as what you have in your sketch. Okay, otherwise you have to flip around and that's sometimes going to be a little bit cumbersome. So in order to flip this guy, I have to rotate it about y-axis. So let's actually I moved it by 90 inches, so that's not what I want. This not what I want. I want to pointing it upward. Okay, so now we got that. So we got the first one assigned, so I'm going to hide this guy now and then go to the crank. I have some shortcut keys that I'm using to do this. And you will see this when I'm doing this. Now the second one is to assign a local coordinate system here, and then again I have to activate this guy. So how I do that is go activate that body. I need to go back to assembly 4. Now I have selected this one. I'm going to say local coordinate system, and here I'm going to pick this edge and say concentric. Once again, I don't like the way it is assigned or aligned. I'm going to rotate it about z-axis. So let's rotate it about z-axis 180 degrees. And then I'm going to rotate about x-axis another 90 degrees. So see, yeah, so this is the orientation I want for this coordinate system. My attachment mode is complete. I'm going to get out. So now we got 2 out of 4 parts done. So I'm going to do the shaft next. So I'm going to hide this guy and bring the shaft in. And let's orient this guy. Okay, so we got the orientation correct. Now in order to assign a local coordinate system, I need to make it active. Go back into the assembly again. Now this is active. Now here I need to create 2 points at the center of these circles, so that I can assign the coordinate system. So I can do that by going to new point and pick this guy and say center of the curvature, Now we have to put another point. Now let's assign the coordinate system. So what you do is you pick this point. Now it's pegged. It has some error. Let's go and pick this again. Okay, now say translate origin. Pick the second point. It didn't somehow pick it, so you can go back and start picking this again. See that? Okay, so I want OXC system defined. Once again, I think I need the orientation different way, so I can now my X is in this direction. So what I can do is to get the Z in this direction, I'm going to say pick this guy and see. Okay, now I got the orientation I want, so everything is good. I'm going to exit out of it. So I got 3 paths already defined with the appropriate coordinates, local coordinate systems. Now let's bring these paths into our assembly. So I'm going to hide this guy and make this guy active. Now in order to bring, I need to insert a link part button. So then first I will bring is the piston. Say pick on that and say insert. Now here it says the selection link, so that's the piston. Now I can pick that coordinate system, which is the local coordinate system in the piston, and then I need to pick the assembly, and then I want to position where it is. So I don't want to position it the origin. This is not where I want to put it in the local coordinate system 1. So let's do that. Now since we are kind of aligned our coordinate system, the piece part coordinate system similar to the coordinate system in the sketch, so you can see it is clearly aligned the way I want it. So I'm going to say yes and exit. Then let's bring the next part. I'm going to bring the crank this time and pick the crank, and then pick the local coordinate system 2. Once again it is aligned the way I want it. I'm going to say okay, and then the next one is the shaft. Pick this guy and the assembly 3. Okay, so we got all these 3 parts now done. They are aligned properly. Let's play and see how this animates. Okay, so go to animation. I'm going to give, let's say, loop and start animating. So you can see piston is going down. Or maybe I can kind of increase the speed by, let's say, 10. Okay, see. So you can see now it's properly animating. So if you got everything correct, you will be able to get this animation working as shown here, where you have a rotation converted to a slider or translating motion. So this tutorial kind of gives you the fundamentals of how you aligned parts and how you create coordinate systems, and how to align parts with respect to those coordinate systems to get a complex animation. And I will put out some more videos down the road on animations, but if you have any questions or comments, please leave in the comment section. Hopefully you learned something new. I appreciate if you could subscribe and give us a thumbs up, and we'll see you in the next tutorial. Thank you.